Okay, so this next unit is focused mainly on adding logic to our programs, conditional operations. I would like to first just go through all of the operators in Java, every one of them, and and this is not keywords, but it's just operators, the different symbols, mostly math symbols, and then show how those work with conditional statements. So we've seen the simple assignment operator. This page right here, docs.oracle.com, blah blah blah. I've linked to it for this assignment. Um, it lists all the operators. So the assignment operator. This is the operator that's used to store a value in a variable. So it's the single equal sign. And you have the value on the right and the variable on the left, and it will take the value on the right and store it in the variable on the left. If the thing on the right is a complex expression, it will evaluate that expression, and then it'll take the result of the evaluation and store that in the variable. Okay, arithmetic operators, those are should mostly be familiar from math class: addition, subtraction, multiplication, division, with the exception of this remainder operator, sometimes also referred to as the modulus operator. So let me just show the modulus operator real quick. If x is 16 and y is equal to 3, and I'm just going to comment this stuff out for a minute. Then let's print out x modulus y, and it should print out 1. So when I run this, I get a 1, and then a 16 because I'm printing x also. So what does it mean, 1 modulus y? It means what is the result what is the remainder when x is divided by y? So remember in elementary school, before you knew fractions or decimals, if you were to do a division like 16 divided by 3 and it did not go in evenly, you had a remainder. So 16 divided by 3 is 5 with a remainder of 1. So x modulus y is the remainder of 1. That has a lot of useful, there are a lot of useful tricks that you can use the remainder operator or the modulus operator for in programming. The unary operators, so these arithmetic operators are considered binary operators because there's a thing on the left and a thing on the right, and the whole expression is evaluated. The unary operators are called unary, not binary, because they only have one operand. It's either a thing on the left or the thing on the right. So the plus operator, that's useless. I never use it. It doesn't do anything. The unary minus is just a negation. So if you take x and you put a minus in front of it, it'll print negative 16 instead of 16. If it's positive, it makes it negative. If it's negative, it'll make it positive. So say I've got a negative 16, and I take the negative of that, the negative of negative 16, it gives me a positive 16. So you should be a little bit familiar with the unary minus operator. Plus plus and minus minus, you'll see a little bit. Those are shorthands. So x plus plus is exactly the same as x is equal to x plus 1. Okay, so it's just a shorthand. However, there is a little bit of a difference between plus plus x and x plus plus. So we can see that here. I'm just going to say plus plus x, and get rid of this stuff, and run that. We'll make x positive so it's a little bit less confusing. So x is 16, plus plus x adds 1 to x, and then evaluates to whatever is stored in x. So if x had 16 in it, you add 1, x becomes 17, and then the expression evaluates to 17. If I change the order and do x plus plus, it first evaluates x, and so it prints out the 16, and then after it's done evaluating, it adds 1 to x. And so in the very next statement, you can see that x had the 1 added. So it's a little bit different if you put the plus plus in front or behind. Minus minus is the same thing, except it's similar. It's subtracting instead of adding 1. Equality and relational operators. Okay, so if we're going to use the double equal sign, what we've got is some kind of expression that's going to evaluate to either true or false. It'll evaluate to true if the thing on the left is equal to the thing on the right. So right now x is 16, y is equal to 3. So x equals y will evaluate to false. Okay. Note that the double equals is very different from a single equals. The single equals is assignment. Single equal is used to store a value in a variable. The double equals is to compare two values. Not equal. So that's exclamation point equal. That evaluates to true if the thing on the left is not equal to the thing on the right. So since x is 16 and y equals 3, x not equal to y is true, because 16 is not equal to 3. Greater than? X is greater than y, because 16 is greater than 3. And greater than or equal to, well, if they're equal, it will also evaluate to true, where this one, if they're equal, will evaluate to false. Less than or equal to. You get the idea. And or. So x is greater than y and true. Okay. This is going to evaluate to true. So Java will evaluate this expression and this expression, and if they're both true, then the whole thing is true. Or Java evaluates this expression, it evaluates this expression, and if either one of them is true, the whole thing is true. Okay? With the and, it's only true if they're both true. With or, if either one of them is true, then the whole thing is true. Now Java has a special little thing that it does called short circuit analysis. Okay? What if I set x plus plus equals 0? Okay? If I run this, x stores 16. X plus y is equal to true. X plus plus should have added 1 to x, but when you print out x down here, it's still printing 16. It never evaluated the x plus plus equals 0. Why not? Because Java first evaluates the thing on the left. That evaluates to true, and then it sees an or. It says, well, if either the thing on the left or right is true, then the whole thing is true. I don't have to bother evaluating this one because I already know that the whole thing is true. Okay? What if you said x is less than y and so x is less than y and x plus plus 0. Well, this whole thing is only true if they're both true. X less than y. That's false. As soon as Java evaluates this, and then looks at the and, it knows that the whole thing's going to be false, so it doesn't bother evaluating this. However, if I flip the sign of this, the whole expression is still false, but x greater than y. That's true. X is bigger than y. And, well, the whole expression might be true, and so Java then has to evaluate this part. It ends up adding 1 to x, and then figuring out that, well, it evaluates this as false and adds 1 to x. And so x ends up as 16, and since this statement is false, it prints a false. So the relational operators, conditional operators, they can be a little bit tricky. Please be careful. I'm going to ignore the ternary operator, the type comparison operator, and the bitwise and bit shift operator. Now notice that I've been doing this and or. It is important to understand which keys on your keyboard get these symbols. So the and, it's also sometimes called ampersand, but if you hold down your shift key and tap the 4 in the top of your keyboard, no, I'm sorry, tap the 7 twice. That'll give you this. And then the or, if you hold down shift, and if you've got an enter key, there's a key directly above it if you tap that key twice. Now on your computer, on your actual keyboard, this may look the same as it does on the computer screen, just a vertical bar, but on your keyboard it might look like 2 short bars with a gap in the middle. That's okay. It's still hold down shift, tap the key above the enter key twice, and that gives you an or. So interesting thing about types. If you're using this kind of and or, it's expecting that the thing on the right and the thing on the left evaluate to Boolean values. They either evaluate to true or false. If I said 5 or, oh, Java's already complaining. What's the complaint? It says the operator or is undefined on the argument type int. Okay, so it's complaining. It says you can't compare a 5 with an or operator. It only understands if this is true or false and this is true or false. And that's why the relational operators work well with the conditional operators. Because if you take a relational operator, something on the left, something on the right, that whole thing will evaluate to true or false. It's also important to understand a little bit of precedence. So the highest precedence goes to the arithmetic operators, and then the relational operators, and then the conditional operators. So the idea is that, say I have x, if x plus 5 equals 0, okay? So when Java evaluates this expression, it's as if there are parentheses first around the x plus 5 because it gets higher precedence, and then around the equals 0 because it gets higher precedence than the relational operators, and then parentheses around the last thing, so where your parentheses control your order of operations. So Java will work from the left to the right, inside out, respecting precedence rules, and you know that multiplication and division come before addition and subtraction, just like in math class. But when in doubt, you can always add parentheses and get exactly the result that you want. I will continue with if-else statements in the next video.